Hi, and welcome to Cardano Starter Kit number 3. My name is James, and the name of this starter kit is Where Does a Blockchain Fit in the Developer Stack? We're going to break down this question, and I want you to know that this starter kit is an experiment. I'll describe it more in just a moment. Before we jump in, please know that this is a first draft, and I expect to have to redo it. So what I ask of you is that you provide your feedback. If this starter kit raises new questions for you that you wish were answered here, or if I say something that you think there's a better way to say, please reach out. Please be in touch. As we figure out how to drive the adoption of Cardano, share what these tools are and what they can do with as many people as possible, we all have a lot of learning to do. So I really hope that if anything in this video resonates with you, you'll also share how to make it better. With 2 new colleagues from Project Catalyst, we've launched a project called Gimbalabs. Our mission is to mobilize everyone in the Cardano community by creating tools and real-world use cases that ignite the public imagination and facilitate adoption. We envision a world where as many people as possible are empowered to solve problems using the Cardano platform. I believe that Cardano can be a force for good that redistributes power and access to opportunity across the world in new ways. And I'm always aware that there's no guarantee that this will happen. This blockchain is only as good as the people contributing to it, and it's up to all of us every day to try to live up to these ideals of building a system that accomplishes these higher level goals. I also believe that some of the people who have the best ideas for what we can do with Cardano now that it exists haven't even heard about it yet, especially people who might not even consider themselves technical. We need to expose those people to what Cardano is and what it can do, so we can learn from them what sorts of problems it can solve. So again, this starter kit is an experiment in trying to make those dreams come true. So hopefully, if you're here and you're aboard, you can kind of, again, give feedback for how we can best do that. Okay, so here's the learning targets for this starter kit. First, I want to try to help you understand the role of a blockchain protocol in a development stack. So we'll start by defining what protocols are in the first place, and then we'll look at what the development stack consists of. And I guess I'm talking in particular about web-based development, okay? So we'll come back to that. Next, if you've never seen HTML, CSS, and JavaScript before, the second video in this starter kit is an introduction to that, just to kind of give you the background on what each of those tools do. I'll show you really quickly how to use GitHub Pages to publish a basic web page. Pages is a great tool because it allows you to test out ideas, okay? And you'll see more about that. In the third video, among a few other things, I want to show you how to set up a development environment on your computer so you can start building. And as I show you in that video, this is kind of the hard part, okay? So we'll get to that in video 3. And then in the fourth video, we'll work together to create a web app that calls on external data and changes its display based on user input. Okay, so a simple app. It's a crypto quote app where the user can type in the symbol for a cryptocurrency and then get the current price of it. At the end of this starter kit, you'll know enough about development to understand what you need when you have an idea that you want to build. This starter kit will not make you a developer. It'll just serve as the first step on your journey, okay? And even if you don't want to be a web developer, if you have an idea and want to start a business, This video might help you just learn what the web app part entails so that you're more informed about what sort of team you need to build to bring your ideas to life. So let's jump right into it. What is a protocol? We hear this word a lot. Maybe if you've heard of HTTP, you know that it stands for Hypertext Transfer Protocol. You see this word a lot. Maybe you've heard that blockchains are protocols. But what is it in the first place? It's actually a very simple idea. A protocol is simply a set of rules for how two or more parties can communicate. When we use protocols, what we're doing is we are trying to remove the overhead that can be spent when you're trying to agree on the rules of engagement. If I want to have a conversation, it's much easier to share my ideas and to engage in problem solving once I know the terms of that conversation in the first place. Protocols can provide those terms. To make it easier to understand, let's look at a few examples. One example of a protocol is knock-knock jokes, right? They're always 5 lines. They always start with knock-knock, and then another person responding, who's there? And then person number 1 says something, Olive, and person number 2 repeats, Olive who? And then comes the punchline. And it's often wordplay, right? Successful knock-knock jokes have some sort of pun or wordplay. And listen, I'm the father to 2 young kids, so I've done my fair share of knock-knock joking over the last few years. And trust me, not all knock-knock jokes are even good or make sense, right? But this is the thing. Kids understand the protocol. They understand the rules of the joke. And as a parent, what I really love about knock-knock jokes is they provide me with the infrastructure to teach my kids about puns and wordplay. Okay? We can all discuss whether or not the punchline makes sense. Once you know the rules, you can operate within them to learn or communicate other things. The other thing you can do once you know the rules is you can break those rules, of course, right? So one of the most famous knock-knock jokes is the one where person 1 just keeps saying banana over and over again. Banana, banana who, banana, banana who, until finally person 1 breaks the cycle by saying orange, aren't you glad I didn't say banana, right? So once we know rules, we can bend and break them within certain constraints. Okay. Now, as a teacher, I've used a lot of protocols over the years. So I'm just sharing a web address here. I'll leave this for you to check out. Okay. But the National School Reform Faculty keeps a library of over 200 different conversation protocols on their site. And these protocols range in purpose. Some are just for having a conversation, getting to know new people. Others are for critiquing each other's work or solving hard problems. The beauty of protocols is, again, they set the rules of engagement so that people can focus more on ideas. And I know that some people bristle at the idea of having those rules set in advance, as if maybe that's a limitation on freedom, for example. The truth is that protocols open up freedom to dig more into ideas because we no longer have to worry about the rules of engagement in the first place. Over and over again, working with both students and teachers, I've seen how protocols serve to draw people out. Somebody who might be reticent to answer some kind of broad, open-ended question is willing to participate in a protocol. Protocols allow us to focus on information and ideas. The entire internet is built on protocols because imagine if you needed millions of computers talking to each other, but every time they had to agree on what the rules of communication were in the first place, we never could have invented the internet. The internet's built on actually dozens of protocols. There's all sorts of little pieces that are put together to make the whole thing work. Some of the most popular ones, you've probably seen this abbreviation before, TCP/IP. That stands for Transmission Control Protocol and Internet Protocol. The Internet Protocol dictates how different machines on a network talk to each other. And the Transmission Control Protocol lays out a standard for how packets of data are transmitted across networked computers like on the internet. HTTP is the language of the web, Hypertext Transfer Protocol. We'll talk more about that one in just a minute. And it's not the only kind of top level, or application layer protocol. There's other ones like FTP, File Transfer Protocol, SMTP for transferring email, and there's more. Now, I'm going to use a few continuums over the next few minutes, okay? And so I just want to share a pretty simple one that I hope you'll agree with. If we say hard things are over here on the left and easy things are over here on the right, we can say that creating protocols is hard and using them is easier, right? And what I love about continuums is that we can place things anywhere in between, right? Very hard, sort of easy, really easy, okay? Now, part of what makes creating protocols hard is, you have to be precise. You have to get it right. But it's also that it takes time, okay? So experience and experimentation leads to creating robust protocols. And once we have enough experience, then we're ready to codify the protocol and start sharing it with others so they can use it. Now, the internet, like I mentioned a few minutes ago, has a whole bunch of codified protocols, and they're organized into 5 layers. At the basic layer, we need physical infrastructure. Then there's a layer called link built on top of that, which sets the rules of how devices or how data is transmitted through wires on the through wires on the Ethernet and through waves, through the air and Wi-Fi. We've got that IP, the Internet Protocol, that shows how different devices can connect in the first place on a network, and the TCP protocol that shows how packets of data are transmitted across that network. And then finally, with all of this, we then have the application layer with these different protocols and more that allow us to actually build stuff. Now, as we move up through these layers of the Internet Protocol, we abstract away the ones below it. So, for example, at the physical layer, the Internet can't exist without servers connected by cables, and maybe some satellites transmitting data, cell towers, and more. There's a lot of different physical tools. There's all sorts of physical infrastructure you need to be able to transmit data in the first place. And there's protocols for that, right? There's rules about how a server works and what a cable consists of. But once those decisions are made, once that physical network is built, we don't have to worry about it too much anymore. Now, this is kind of hard to see as we move up through these lower layers because, for example, I can't imagine inventing the TCP and IP protocols, right? That's expert level work that a lot of really smart people committed their entire working careers to getting that right. And at the link layer, defining Ethernet and Wi-Fi specifications does rely on developers and engineers to understand the physical limitations of all of this stuff, right, at that basic physical layer. But by the time we get to the top, if I want to use FTP to send a file, if I want to use HTTP to build a website, all of this stuff below can be abstracted away. Now, I should be grateful that it exists. I don't want to forget that these things exist. But in my day-to-day life developing a web page, I don't have to spend too much time thinking about these layers beyond my sense, beyond my sense of gratitude. All right, so another continuum. I hope we all agree. Building network infrastructure, that's really hard. Inventing the internet, hard. But posting to Instagram, that's easy because it abstracts away all of this work that went into building the network that we use every day without even thinking about it. To tweet, to search for things, to post to Instagram and Facebook, and on and on and on, right? Because all that other work has been abstracted away, things like posting to social media are now easy. And it wasn't always that way. It used to be really hard just to have a picture on a computer. There were tech limitations to it. There were no standards for image formats, okay? But over the years, those things got easier. The more time we have with technology, the more layers of abstraction can emerge. So, before we move to talking about blockchain development, I just want to name that in between these two ends of this continuum, there's a lot of different flavors or gradients to what development actually means. Okay. I think a lot of time it's easy to have this monolithic idea about what a software engineer or a developer is. But the truth is, inventing Marlowe, that's really, really hard. Inventing a domain-specific language to be used on a blockchain, that's hard. But building a web app has actually gotten a lot easier. You still have to pay attention. You still have to practice it and study it a bit to be able to make the most of it. But because we have so much experience building web applications, there's a lot of work that you can lean on that other people have done. So you're never starting from scratch when you build a web app. Likewise, now that Marlowe is invented, okay, by Professor Thompson and everybody else who worked on that, now that it exists, this abstracts away a lot of the complicated stuff so that people like you and me, we can go to the Marlowe playground and interact with financial contracts just by dragging and dropping blocks. Think about all the layers of abstraction that went in to developing the Marlowe Blockly editor. All right. So development exists on a continuum. And my goal, I don't know if I left this in the perfectly accurate spot on the continuum here, but the idea is that building a web app is closer to the easy end than I think a lot of people realize. And I'm doing an experiment today. I want to see if by doing the rest of this starter kit, I can get you to agree with that. Let's talk about blockchain for a minute and layers of abstraction, okay? So, another example, designing blockchain protocols in the first place, that's really hard. And when I notice that, I'm grateful for all the people who have dedicated years of research and development to building these protocols so that they're ready to work in the world. Hopefully, now that Cardano, for example, exists, the end use cases can get easier and easier, more accessible and more accessible for people to use them. Maybe you've heard these terms layer 1 and layer 2. This is sort of similar to what I was showing you with the layers of internet protocol before. Cardano provides the basic infrastructure to do all sorts of new things, not just transfer value, but to write smart contracts and to add governance. You know the list, and we'll talk more about that as time goes by, right? But now that we have that technology, we are just starting to be able to build what are called layer 2 solutions, new tokens on top of Cardano, new additional protocols on top of Cardano that use Cardano's infrastructure to add another layer of abstraction so that even more people have access and ease of use to these new tools, okay? So layer 1 is the basic blockchain protocol. Layer 2 are the new protocols that are built on top of it and use that infrastructure. As more and more solutions come out, hopefully it'll get easier and easier for people who are not expert developers to use these tools. This is a work in progress, and a lot of us have a lot of work to do. So I wrote this as a question here, right? We hope that those end use cases are easy. We hope that as layer 2 solutions arrive, more and more people will be able to build on top of that to solve real world problems. Now, just to reiterate, when you're talking about web development, we can say that all of the lower levels, all the layers below the application layer have been abstracted away, right? We don't have to worry about Ethernet cables. We don't have to worry about TCP/IP. We have to worry about these 3 concerns right here. What happens on the user's device? What happens on the servers that comprise the internet? And how are we handling data, information, and files? Often, developers will specialize in one of these, right? So you'll have front-end experts who are really good at designing beautiful web pages and user interfaces. You'll have back-end experts who are really good at making sure that the right things happen as efficiently as possible on servers before requests are sent out to end users. And then we have database experts who are really good, once again, at efficiency and making sure that information is stored securely and in a way that it's not going to be, compromised or changed. Okay. If you ever hear the phrase full stack developer, that's somebody who knows how to do all 3 of these things and can build a working system consisting of all 3. But these days, there's so much to know in order to become an expert on any one of these that a lot of people will specialize. Okay? So now, forgive me. I know I jumped ahead a little bit. What's this diagram all about? Well, let's look at it a different way. When we talk about the HTTP protocol, Hypertext Transfer Protocol, I guess the word protocol is redundant here, sorry. Okay, the HTTP protocol works by having information move from servers to end users on all their devices. The internet just consists of a bunch of different computers connected together as a network, right? So this little messy diagram right here represents a fraction of a fraction of a fraction of the entire internet, right? So take these 3 servers and turn that into, I don't know, are there millions of servers on the planet Earth, right? And billions of end user devices, okay? And what HTTP does is it sets the rules for what sort of information moves back and forth between servers and end devices so that the right information, the right web pages appear on users' screens. Now, what's HTTP good for? It's really good at transmitting data and information, right? This could be text data, it could be quantitative data, it could be videos and images and all that. Everything that fills up web pages that you go to, any information that makes the web worth using, HTTP is really good at transmitting that. But as we've seen in the last few years, HTTP is not always good for transmitting trust. It's not always a secure protocol. And yes, most web addresses now have HTTPS on them, right? Which is technically that stands for HTTP over TLS, which is transport transport layer security, right? So if you can imagine that TCP protocol, right? How can we add security at that layer to ensure that the HTTP is more secure at the top layer, right? But even that's not perfect. And trust is a really thorny problem right now on the internet. We see this on social networks. We see this in all sorts of different flavors of information campaigns. It can be really hard to know what's true. So, this is really where the blockchain comes in. There's a few different ways to define what a blockchain is, right? And we could talk about it in terms of the technology. We could talk about where the word blockchain comes from in the first place, right? This chain of packets of information that are tamper-proof, this idea of a distributed permanent ledger. But let's abstract it just a little bit. What a blockchain really is a protocol for transmitting trust. Just like HTTP is a protocol for transmitting data and information, a blockchain can transmit trust. If you're watching this video, you've heard about Cardano, so I'm not going to try to go through everything that it can do. I just want you to have this high-level idea of a blockchain as a trust transmission protocol. And just like HTTP, right, just like the internet consists of servers and end users, Cardano is built the same way, right? We have nodes, we have stake pools, and then we have delegators, and then we have everybody with their light wallets like Yoroi interacting with the blockchain, okay? And this image right here, I'm so sorry to whoever created this. And please, if you know who made this, if you recognize this, please let me know, because I know I grabbed this over the summer when it was first posted, and I can't find the reference to it online. And so I want to make sure to properly attribute whoever made this. And if you don't want it here, no harm. I'll just take it down. Okay. But I just love this image, this visual of what the Cardano network, at least back in the summer, what it looked like. And it's only growing from here. Now, when you have, let's say, let me go back. When you have databases, when you have servers with all sorts of different information on them, and you know, Twitter's server has this information and Facebook's server has that information, right? How do all these different databases, all these different stores of information talk to each other? How does one protocol like Cardano talk to another? If I'm building web-based applications that mostly rely on HTTP, how do I inject a little bit of blockchain into those? Well, the answer is in application programming interfaces, or APIs, okay? APIs provide a protocol, provide a standardized way for transmitting data, for what kinds of data and what kinds of requests can be made. So this is the focus of this starter kit, okay? What we're going to look at today is just the front end of web development. I want you to have enough background knowledge so that you can understand better where blockchain fits in the development stack. To do that, I'm not actually going to cover blockchain too much today. I want to cover front-end web development to give you, to build your schema, to build your understanding of what happens on the front end. Okay, I want to show you how, because this is mature technology, because HTTP has been around for over 2 decades, we never have to start from scratch. A lot of concerns have been abstracted. And an extreme example of this would be website builders like Wix and like Squarespace, where you actually, all you have to do is drag and drop a lot. And that's great. Those tools are actually really powerful, and I use them sometimes when I need a website really quickly, okay? But even if you're not using those tools, you never have to just start from nothing when you're creating a web app. So I want to show you what tools exist. And at the end of this starter kit, I want to show you just for the very first time how to interact with an API, just so you know what this looks like. And then I'll provide some resources that you can use to follow up. We're not going to cover blockchain, and there's a heck of a lot more web development stuff we're not going to focus on. We're not going to do any back-end work, okay? We're not going to do anything that happens on servers. We're not going to do anything with building a user authenticator or databases. We're not going to do anything with security. Deployment is when you move from a developer environment to a live publicly accessible web app. And actually, we are going to touch deployment just a tiny bit when we talk about GitHub pages, but we're really not going to do this topic justice, okay? We're barely going to do front-end web development justice. I'm just going to give you a starting point. This is a starter kit, okay? So I want you to have enough background knowledge to understand what your next steps might be. These are the tools we're going to use today. Now, all of the web is built on HTML and CSS, right? Hypertext markup language, which is transmitted over HTTP, and CSS, which stands for cascading style sheets to style what appears on a web page. JavaScript is the predominant programming language of both the front end and the back end of the web. It's not the only one, but it might as well be in a lot of cases, okay? With some of these other things, we have a lot more choices. There's a lot of IDEs or integrated development environments out there. I'm going to show you one called Visual Studio Code, which is free from Microsoft. Node.js, we're going to cover this in video number 4. It's called a JavaScript runtime environment, but I know those are a lot of big words, so I'm not going to rush into explaining all of that right now. We're going to use a front-end library called React and a front-end toolkit called Bootstrap. These are definitely not the only tools for the jobs they do, but they are very popular and they're very well supported. And it's funny, when I think about this in my mind, Visual Studio is built by Microsoft. React comes from the developers at Facebook. Bootstrap comes from the developers at Twitter. So we are relying on free tools made by Microsoft, Facebook, and Twitter. So I have a long way to go towards using maybe more decentralized tools. But all three of these, actually, I don't know if Visual Studio is open source, but React and Bootstrap are open source. Okay, anybody can add to them, change them. We're going to use a promise-based HTTP client called Axios to make our API calls. This is not necessary, but as I'll show you in the 4th video here, I just want you to see how to use this tool called NPM, which you'll learn more about in video number 4, and we'll use Git and GitHub for version control. Again, these are all choices, or I should say some of them are choices. HTML is not a choice. Node.js is not really a choice, okay? But others are. React and Bootstrap are definitely choices. And my goal in showing you these first is that you'll be better informed on what the choice is even about, so that if you realize, ooh, I don't like those so much, you'll have context for choosing something better. On GitHub, you can find the documentation to accompany this video, and I'll share it in the link below. The documentation is really easy to edit. So my goal here is to make changes to this documentation until it's to a point where it's clear that it's the right time to remake this video, right? It's kind of harder to edit an open source video than it is just to change a little bit of text right here. But just to show you what's here so far, there's links to all 4 videos, including the one you're watching. To continue from this video, you can read more about internet protocols by just clicking on these links. This is actually a sub link from this professor's course at Sonoma. And then this is fun. Here's 3 layers that you can dive into to learn more about Cardano's protocols. You can read a blog post that takes just a few minutes to read. You can read Cardano's extensive documentation that's getting better and better every day about how the Cardano network works. Or you can go even deeper and read about the Shelley networking protocol itself, okay? There's a lot of amazing research out there in Cardano land. And, you know, I honestly, I can't even get through all the research papers. I don't have all the background knowledge it takes, but it's really fun to try and just to see how much I understand. So see if you can work through these in order. Each one is at a higher level of complexity and maybe a lower level of abstraction, right? The blog is highly abstract from, at least when compared to, say, the research papers or the technical reports. Okay. How do we continue from here? In part 2, we're going to party like it's 1999 and just use some basic HTML, CSS, and JavaScript. This is for anybody who's never seen these things. Then, if you've never set up your own developer environment, that's what part 3 is about. And finally, part 4 is the longest video of this starter kit. It'll take you through building your first interactive app with React, Bootstrap, and Axios. Again, there's different ways to share with you what I'm sharing here. And I would love your feedback on how to say it differently or better, all right? Once you dive in, you might find that there's better tools than React and Bootstrap out there. I want to hear about your journey. That's fantastic if you come to that realization. These are not necessarily my favorite tools. I'm choosing them because of their accessibility and popularity. Finally, if you are a developer and there's different things you want to add, I would love to hear that from you. My goal with this starter kit, right? I said at the beginning, this is an experiment in how can we make this information as accessible as possible. And I'm going to keep tweaking it until we find the best way to do it, okay? Find the best way to really mobilize as many people as possible to get on that learning journey. So thanks for checking out this video. I hope to see you in part 2, where we party like it's 1999. Take care.